Machholz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 4 for the week of January 29th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. So, what's up in the sky this week? As our week begins on Wednesday, January 29th, and by the way, our week always begins on a Wednesday, goes through the following Tuesday. The moon is a thin crescent in the southwestern sky about an hour after sunset. Now, the previous 2 days, it slid past the planet Venus. Now, as you face west, the moon is above Venus. With each passing night, the moon moves eastward about 12 degrees, sets about an hour later, and is more illuminated and therefore brighter each evening. By next Tuesday, February 4th, the moon will be bright at 70% full and high in the eastern sky after sunset. For those of you in the United States or Mexico, you can observe the moon pass in front of the star Epsilon Tauri on the evening of Monday, February 3rd. Let's talk about moonlight for a few minutes. The position and illumination of the moon affects astronomical observation. The amount that it affects you depends upon several factors. A bright moon can wash out a meteor shower so that it will appear less spectacular than it would under a no moon condition, because you just will not be able to see the fainter meteors. This is one reason why a meteor shower may be good one year and not so good the next. The moon phase on any particular date will be about the same on that same date 3 years later. Therefore, any particular meteor shower, and they occur on about the same day each year, will have a good year with no moon in the sky, a bad year when a bright moon is in the sky, and a hide-and-seek year when the moon is problematic and you have to observe the meteor shower in the hours before moonrise or after moonset. A bright moon also reduces contrast. It makes it more difficult to see extended objects such as nebula, galaxies, and comets. Less affected by moonlight are point sources such as stars and brighter planets such as Venus, Mars, Jupiter, and Saturn. Faint stars, however, can be washed out by a bright moon. How well you can see in moonlight also depends upon where the moon is in relation to where you're observing. If the full moon is in the eastern sky and you're looking west, you'll see better than if you're looking east towards the moon. It also matters as to whether the moon is shining directly on you or not. If it is shining directly on you and illuminates your telescope and the ground around you, you'll not be able to become dark adapted enough to see well through your telescope. For a public star party, once I had little choice but to set up underneath a street light. I could see almost nothing through the telescope. The street light was not illuminating the sky very much, which is the definition of light pollution. It was illuminating the telescope and eyepiece and surrounding ground. So that's what made it difficult to see anything. This is known as light trespass. Similar situation is when your neighbor has a porch light on all night and it's illuminating the location from which you're doing your astronomical observation. A thick, dusty atmosphere also scatters the moonlight more than a clear, pristine atmosphere. So if you're at an elevation of 7,000 feet, you will do better than you would at sea level. Finally, it matters as to how bright the moon is. As a thin crescent, it casts little light into the night sky. Now, when it reaches a full phase, it casts quite a bit of light. I find that 3 days before full phase and 3 days after full phase, the moonlight greatly hinders visual observation. For my comet hunting, I've learned from experience that when the moon is more than about 40% full, it reduces my magnitude grasp through the telescope by about a magnitude or more. I had originally set this mark at 33% and avoided comet hunting when the moon was more than 33% full. But by the mid-1980s, I revised that to 40%, finding that when I sweep the sky away from the vicinity of the moon, I would then lose only about a magnitude. I will sometimes go out comet hunting when the moon is greater than 40% illumination, when I'm sweeping the morning twilight sky, which is already hampered by twilight. However, having said all that, when the moon is out, observe the moon. It looks great through any instrument. I love looking at the moon, and I'll never get tired of observing the moon through a telescope. In the evening this week, you'll also see the planet Venus in the southwest. If you've been clouded out for the last few weeks or few months, your first view of Venus in the southwest shining so brightly could be quite shocking. But that's the planet Venus, and over the next few months, it will get a little bit brighter and higher in the sky. And don't forget to look to the east and check out the red star Betelgeuse in the constellation Orion. It's dimmer than usual, and I suggested last week you go out and make magnitude estimates of it for yourself. I did that on January 22nd, and I saw it at magnitude 1.5. It was fainter than 1.4, but brighter than magnitude 1.6. Now you can still make estimates of the brightness using Star Map 1 from Podcast 4, which has the magnitudes of some of the stars written on the map. If you enjoyed estimating the magnitude of Betelgeuse and would like to do this on a regular basis, then get involved with the American Association of Variable Star Observers, or AAVSO. This is a worldwide organization dedicated to the observation and accumulation of data about variable stars. That is, once again, AAVSO, American Association of Variable Star Observers. So what do we find in the morning sky this week? We find a moonless sky, so it gets as dark as it will ever get. So if you want to observe the galaxies in Leo and Virgo and up through the Big Dipper, stay out after moonset and have a go at it. Just before dawn, you may be able to pick up the planet Jupiter low in the southeast. The International Space Station this week is visible in the evening sky for the northern hemisphere. Meanwhile, our friends in Australia and the rest of the southern hemisphere can see the International Space Station in their morning sky. For those near the equator, plus or minus 15 degrees or so, you'll probably not be able to see the International Space Station at all over the next week. It all depends upon where the International Space Station is during your dusk and dawn. You can go to the website heavens-above.com, enter your location, and find out where and when to see it. You can also use heavens-above.com website to find out where and when the latest set of Starlink satellites are to be visible. These are the ones that are launched in batches of 60, and then go out and have a look. This week for our Unaided Eye Challenge, we're going to learn a constellation. Now, the sky's made up of 88 constellations. A constellation is a group of stars that forms a recognizable pattern in the sky. It's good to know at least a few constellations, and this week we begin with one that's called Auriga, A-U-R-I-G-A. For this, you'll need to download a map from my website, Podcast 4, Star Map 1. Now, normally, you would face south and hold the map over your head, right side up. But for seeing this constellation, Auriga, face north and hold the map upside down. The constellation Auriga will be very high in the sky and slightly to the right. Now, the constellation Auriga is in the rich Milky Way. It's made up of 5 bright stars forming a pentagon. The brightest star is named Capella, and it's the 6th brightest star in the sky. Capella is 43 light years away, which means the light you see tonight left the star in the year 1977. In the constellation Auriga, we find many open star clusters and a few nebula. Remember, the Milky Way runs through this constellation. 3 of the open star clusters, M36, M37, and M38, we will be looking at in the binocular challenge. So become familiar with the constellation Auriga. As the night progresses, it will move in a large circle around the North Star. And so the constellation Auriga, being so far north, is visible most of the night, nearly every night of the year. The only time it's difficult to see is in the short summer months. Those in the southern hemisphere can best see Auriga in your northern sky these months. The binocular challenge for this week. We are going to use binoculars to observe 3 open star clusters in the constellation Auriga. They are M36, M37, and M38. These are objects 36, 37, and 38 in the Messier catalog. For this, you'll need to download this file from my website, Podcast 4 Star Map 2. I put the coordinate lines on this map. Just note that for a reference, the horizontal curved lines are 10 degrees apart. The field of view of your binoculars are probably between 5 and 8 degrees across. This gives you some idea of the amount of sky that you can take in your binoculars. Let's look at M38 first. There are a lot of stars in this part of the sky, and take a few minutes to sweep around. M38 should stand out when you're looking at the right place. It's about a half a degree across, about as large as a full moon. While something as large as a full moon might appear to be rather large, remember that it's only about a half a degree across, and the field of view of your binoculars is somewhere between 5 and 8 degrees across. Next, we're going to go to M36. M36 is another open star cluster, and it's about 2.5 degrees to the right. You might be able to fit both M38 and M36 in the same binocular field of view. M36, compare that to M38. M36 is smaller. It's less than half the size. With both the clusters, you can see the individual stars, and that's typical for an open star cluster. There is another type of star cluster known as the globular clusters, where the stars are more compact. These are not globular clusters. These are open clusters. Our next step will be nearly 4 degrees and almost in the same direction for M37. So you go about 4 degrees to the lower right, and you'll pick up M37. However, M37 may be hard to see at first. It's not like the first 2 open clusters that you've been looking at. M37 is more diffuse, and the stars are fainter, and they're all about the same brightness, so it will not stand out as well as M36 and M38. So there you have it. 3 open star clusters, all about 4,000 light years away. Before you leave this area, go back and look at M38, 36, and 37. Then take the binoculars away from your eyes, then back up again, and you'll see that you'll be pointing once again at this area. Muscle memory is pretty amazing, isn't it? For those of you with telescopes, with the moon now in the evening sky, it will be more difficult to observe comet Pan-STARRS C 2017 T2. However, you might want to give it a try, and I do have its location plotted on Star Map 2 from podcast number 4. Our telescopic challenge this week is the open star cluster M103. For this, you'll need Star Map 2 from podcast 4. This is the 103rd object in the Messier catalog and was actually discovered by his friend Pierre Messier in 1781. This star cluster has about 40 members in it, and it is longer than it is wide. Unlike most open star clusters, it does not appear to be round. It's colorful, and it stands out from the background. You'll know it when you see it. This week's fun fact. In the late 1700s, about 250 years ago in Paris, France, lived and worked an astronomer named Charles Messier. He spent his nights searching for new comets. A new comet generally appears as a fuzzy object through the telescope, and besides seeing comets, Messier was seeing a lot of other fuzzy things. These objects are star clusters, nebula, and galaxies. Now, to keep from confusing them with comets, Charles Messier mapped and cataloged them, and then he numbered them. Over the course of time, 110 objects have appeared on this list, and they're known as Messier objects, or M objects. We've talked about some already in this podcast: M36, M37, M38, M103. Each object has a number, so the first one on the list is M1. Some are rather popular. M45, for instance, is the Pleiades, M42, the Orion Nebula, and the Andromeda Galaxy, that's known as M31. Incidentally, 110 is a number of Messier objects that most astronomers recognize. Sky and Telescope magazine recognizes only 109 objects, declaring M102 as being a duplicate observation of M101. Astronomy magazine gives a catalog only 109 objects too. It recognizes M102, but it excludes M110. But for this purpose, we'll recognize all 110 objects. Charles Messier also found 12 comets that bear his name, and one more that was named after the person who determined the orbit, Anders Lexell. He also picked up 7 more comets, but too late to get his name attached to them, or in some cases, they were known as the Bright Comet of that year because many people picked it up at around the same time. Despite all this, however, Charles Messier is not known for his comets, but for his catalog. As a novice gets more involved in astronomy, they learn more and more of the Messier objects. They're some of the brightest galaxies, clusters, and nebula in the sky, with most of them north of the equator. It is the northern hemisphere that is favored for the Messier objects. From parts of the southern hemisphere, a few of the Messier objects are not even visible. For mid-northern latitudes, at any one time, on the average, about half the Messier objects are above the horizon. As the night advances, objects in the western sky set, while in the east, new objects are rising. If you wait out the whole night, from dusk to dawn, you have the opportunity to observe at least 85 of the Messier objects in any one night. During late March of each year, it's possible to see all 110 Messier objects in one night. Conditions have to be ideal for this to happen. The moon cannot be bright. Your horizons, especially in the west and in the southeast, have to be low. You need clear skies for the night. You need a telescope of at least 4 inches or more, and you need to know what you're doing out there. In mid-1978, I realized that a Messier Marathon would be possible in late March of each year, and wrote an article about it for the San Jose Astronomical Association newsletter. I based this belief upon my years of comet hunting. By then I had done 3 years of comet hunting, 3.5 years, and was recording all the objects I was picking up while comet hunting, including the Messier objects and the NGC objects, the fainter objects, and what session I observed them at. So I had a long record of knowing when I would first see the Messier objects each year and when I would last see them as they were setting in the west each year. I suggested in this article that we do a marathon in March of 1979. That month, Sky and Telescope published an article about a few guys who had done some informal Messier Marathon in the previous 2 years. I published a search sequence for the marathon, which is important because it helps you pick up the objects setting in the west and helps you work your way across the sky. I later wrote and self-published a book about the Messier Marathon in 1994, and later rewrote that for Cambridge University Press. I enjoy doing Messier Marathons, and since 1979 I've done 53 marathons over the last 41 years, seen 100 or more objects on 40 of those 53 occasions. Now those nights where I don't see over 100, those are times that clouds came in and ended the session. 10 times I've seen 110 objects in one night, and 17 times I've seen 109. Now, why only 109? Well, those nights were mainly from Northern California, where seeing all 110 is much more difficult than when you're further south, such as the southern United States. For the past 15 years, I've been doing the Messier Marathon from memory, that is, no star maps and no setting circles, and a few times even just starting with a blank sheet of paper, no printed search sequence, and writing down each object as I saw it. Now, this actually makes it easier if you know them all from memory, because you're not always referring to setting circles or star charts. You're just going from one object to another, pointing it at the Messier object, observing it, and moving on to the next one. Typically, for me and for some others, the Messier Marathon night is busy for the first 1 or 2 hours, and then I'll pick up the first 65 objects during that time. Those are all the ones that are above the horizon. Then I'll go to bed, get up 2 hours before dawn, and finish up the rest. For others, it's more of a leisurely stroll, staying awake all night and working across the sky from west to east. We also find at some of the Messier Marathons that many of the astronomers will only do the evening set, the first 50, 60 objects, and then go to bed from there. The Messier Marathons are held all around the world. Typically, it's a local astronomy club that will hold them. They're also somewhat of a social event, as most people are up all night, and there is a lot of time to visit. One of the most popular Messier Marathons is held by the Sagrano Astronomy Club in Phoenix, Arizona, and it's held in the desert west of Phoenix. This year it will be held Saturday, March 28th. Once again, that's the Saguaro Astronomy Club of Phoenix, Arizona. It's spelled Saguaro. They have a website. Go to their website, find out more about the Messier Marathon. They have a great group there every year, and you'll really enjoy going there. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll discuss how to photograph the moon with your cell phone and more on the Messier Marathon. Thank you for listening. See the sky this week. I'll see you next week.